Hello, so in this video I want to show you how I prepare a board for a CPU swap. Basically I have an iPhone 13 Pro that has some issues and I need to swap the CPU to a new board. It's not about data recovery, it's just that the board was already swapped on that model and something doesn't work properly. I'm gonna swap it again. And in this video I want to show you the procedure I do to prepare a donor board for this swap. So let's roll the intro and let's get started with it. So the first thing, this is the 13 Pro donor board. It should be a working board. The first thing to test it is I'm gonna connect it to the power supply, and I'm interested if we have a proper boot behavior. So connecting it to the power supply, you can see up in the right up corner you can see the power supply. I'm gonna power on the power supply. You see 7 milliamps current draw, and then it goes back to 0. And now let's see, I don't know if I think I should use the microscope better to prompt it to boot. Let's do it this way. Yeah, so this is the connector. I always forget, I think this is the boot prompt. No, it's not that one. Then it's maybe this one here. Let's see. Yeah, so you can see it's going to 72 milliamps. Yeah, and now it started to boot. I'm interested if it boots properly. Yeah, it looks very fine. It seems a normal boot behavior for a 13 Pro board, so that's fine. We only need the top board. I'm gonna power off the power supply. If we go to ZXW, we're only interested in this top board here, because I'm gonna remove this CPU, and from the other side of the board I'm gonna remove the logic EEPROM that is here. You can see it right here. If we go back under the microscope, the logic EEPROM is actually here in this location under this shield. We're gonna have to remove the shield. It's not something I really enjoy. It's quite difficult to remove it without harming the board. So the first steps we do now, knowing that the board boots, is I'm gonna remove the I don't know how these are called, these foam things that are around the connectors, because we're gonna have to actually split the boards. I think I should use some alcohol on this one because it doesn't want to come off easy. Yeah, so this one already broke. I don't care about it. Let's see the other one. Maybe we can get it in one piece. Yeah, one piece is good. I'm gonna keep it here on the microscope. I like to keep this because when I work on phones I like to put them back after. But if we break it, there's no problem. We're gonna get another one from a different board. But still, let's try not to break them. It looks good. Up to now, all looks good. Perfect. Okay, now I think we removed everything. No, we still have one here. Okay, this one is removed too. Now we can actually remove the big one from here, because I don't want them to melt when I'm gonna split up the boards. And this one is removed too. And now we're gonna remove the ones from the bottom. We don't actually need the microscope now. Let's try this camera. I'm gonna set the hot air to 350. I think you can see it there. And I'm just gonna slowly heat it. You see it's set to 350 40 air. But this is not extremely important. We just need to have some heat on the board so this come out easily. This one is very important, so I don't wanna mess up with it. We need to reuse that. Not necessarily for this phone, but for others. And we also have this rectangular one. Okay, we're good. So that being said, I think it's time to actually split the boards. Let me get the heater. 1 second, because my cables are all jumbled here. Mambo jumbo. Alright, so we have here the iRepair MS1. I need a plate for the 13 model. If I can ever find it. 13 set. We can put the board here. Perfect. So now I'm gonna set this to 230 degrees, and it's set to 40 seconds, I think. So we're fine. I'm gonna wait until it reaches about 200, and when it's gonna reach 200, I'm gonna apply some flux all around the board. Actually, we can put it under the microscope because we will be able to see it better. Okay. Let's see here. We can see only the microscope, and that is good. We're currently at 100 degrees. Gonna leave it just for a while until it reaches a better temperature. Alright, I'm gonna prepare the flux syringe, and now we can actually apply the flux. You probably won't see the full picture, but you see I'm just applying some flux here on this side. Now let's go on this side. Okay. Cool. We're not gonna be able to reach everywhere. Yeah, so I'm just gonna use the areas where I can actually reach with the needle. I don't wanna put extremely too much flux because it's already smoking. I don't have a smoke absorber. Alright, now we can get out of the microscope, and now it's at 195, yeah, and I'm gonna add some heat on it. We're still at 350. If we don't heat it properly, then we're gonna have how's it called? Jesus Christ. Oxidized pads. So oxidized pads I hate. Really difficult to work with. If we heat it too much, then we're gonna have solder coming out all the chips that have underfill. So it's gonna be like solder blobs everywhere. I hate that too. I wanna avoid this. So because this is not a data recovery, I'm not gonna move the NAND from this board. I'm not gonna remove it because we're gonna use this NAND for the new board. Yeah, the old board is 128 gig, so this can't be lower than that. So we are good. Let me find my paper towels. Alright, now first thing, we're gonna clean this thermal compound that's around here, and then just gonna gently remove it off the CPU. Good. So this compound is removed. I'm gonna remove it from the bottom board also, because this one I'm gonna keep for future bottom board swaps. It's a good board and I know I can use it freely. I'm gonna store it back in the storage locker, so we have it in the future. And now that we have cleaned the CPU from the thermal compound, the next step I'm gonna take is I'm gonna actually remove this solder on the pads. I'm just gonna apply flux. On the board. And then I'm gonna apply some low melt solder. I'm using like 148 for this. I'm gonna replace this high temp high melt solder with 148, and then we're gonna wick it. Let me replace the tip. Let's go back so you can see also the temperatures of the solder iron. I'm gonna use this tip now. This is very nice. It has quite high thermal efficiency. It's the tip that I use most often of them all. Let me find the solder. I'm gonna put a hefty blob on the tip, and I'm just gonna gently scrub this and replace the high melt solder. Alright, I'm gonna replace the solder on my tip and put some fresh 148 one. Okay, I have way too much big blob here, but that's fine. Let's go gently. Notice that I don't have the board yet in a holder, because it's actually easier for me to keep rotating it as I need. Okay, I'm gonna go one more time over this. Good. And we are almost done. Okay, now I still have this side here. I had way too much solder on the tip. The blob was too big, so I left this for the end. This is very narrow, so I prefer to use like a smaller blob to be able to clean it. See, I put some solder on that cap. Good. So this is good. Now I'm gonna change back the tip, and I'm actually gonna use like I have an old knife tip, you see, but it's so worn out. So look, as a comparison, this is a newer one and this is the old one. It's so worn out that I'm currently using it only for wicking. It's good because the tip is smaller, and again it has a high thermal efficiency, and it's easier to use a wick like this one, which is quite hefty. Let me see, how can I show it to you? Like this. So I'm using this type. In the past I was using this one from Chemtronics, but this is very it's like very thin, and it's I consume a lot with it. This one I can use just a small piece and have like the whole board done. So I'm gonna cut a bit of this one. I need tweezers for this one, so I'm using like this type of tweezers, ceramic ones. And now let me put the board in a holder, because it's gonna be easier. Let me see how I can fit it so I can wick the most of it, and then I'm gonna switch the position and wick the rest that we couldn't wick, like that. Okay, I think we're good. Let's go back under the microscope. I'm gonna see the temp stays on 380 on the iron. I rarely change it, and I think we can start the wicking process. I think it's gonna be a bit difficult for you to see the whole picture, because the microscope is not really grabbing everything. Yeah, but you see it's cleaning fairly well. With no issues whatsoever. This thick wick has a very good thermal efficiency, so once it's hot you can just suck all this solder here. Okay, and this part is a bit difficult because it's quite narrow, and I want to do it without removing any components, because as I said, this has a very high thermal efficiency, this wick, and just touching something might lose it. Okay, it didn't go very bad, so we're cool with it. Let's get this side. Alright, good. Now I think we can also do this part here, and then we're gonna move the board in the holder to do the rest that we couldn't grab because of the holder. I'm constantly looking on the OBS screen, so I make sure that you see properly. Okay, now let's see how we can fix this one so we can wick the rest of it. Let's see if we can do it like this. So we're kind of good. This is all done. The only thing we have left is this side here. Yeah. So let's start like this. I'm gonna rotate the wick and use the other side, although it has already sucked solder because it's so thick. It already sucked the solder through its whole chunk, you know. Okay, so this board is clean. We can now just clean it a bit, and then we can continue removing the rest of the components and the shield. I'm gonna use this IPA bath. It's a bit dirty, but I don't care that much because we're gonna have to clean this board several times. I'm gonna use this brush yeah, on the sides, so where the interposer makes the connection with the board, where we had the most of the flux, like this. Okay, this is perfect, and now I'm gonna use a soft brush just to clean the whole board. Okay, perfect. And I'm gonna use this cloth just to wipe this. Perfect. We don't need the alcohol anymore. And now I think we're gonna need the... When I have problems here with the wires. We're gonna need the board holder again. We're gonna clean the glue around the CPU. I think we're good like that. Okay, let's go under the microscope. Yeah, so we're cool like this. We're gonna use this tool here. Fuck. I lost my camera. 1 second. Okay, so I think we're back in business. I'm gonna have to actually get this wire here. The power supply from the microscope camera. Yeah, we should have the microscope back in a few. Alright, so image back, we can continue. I'm gonna set the hot air to like 240 degrees. Yeah, to 40, 30 air. Let me get my tool here, and I'm gonna try to somehow make you see the whole picture. And now I'm gonna gently heat up the CPU and its surroundings. I'm gonna heat the whole board. Right. Now let's try to remove this underfill here. It's not very easy, but I need to be very gentle because I don't want to damage any of the parts there. So this is gonna take a while. This is why the swaps are quite expensive, not just because you actually need the tools and you actually need that knowledge and the experience to do it, but it also takes a lot of time. Also, there are phones that have this glue a bit softer, phones that have it harder, so this is very hard. I'm not speaking about different phone models, I'm speaking about the same, so I can get a 13 Pro board where this is actually soft compared to this one, this particular board that is actually very hard. Yeah, but if we pay lots of attention, we can see that it's cleaning properly. Note that I'm almost not pressing at all on this tool. I'm just scraping it gently, and this way it will remove the glue, but it will not push on the sides, you know, to move the small components around the CPU, to push them away. Yes, I think this side is good. We can move to the long one. Let's see here. Here we have a mixture of soft glue, like this one that's over these caps here. This is like soft, you see. It's a different material. And there's also this one that's between the CPU and this row of caps and resistors. That is actually harder, but no problem. We're gently removing it. I want to remove this soft one because this is doing also, it's creating ball squeeze. So when we're gonna apply high temp on the CPU to remove it, that is gonna create issues. Alright. Now we move higher. Let me put you like this. Okay. Okay, so this side is good too. Let's grab the short one, the short edge here. And let's continue with this one. So 13 Pro for me is one of the worst boards to do swap-ons. I don't know why swaps on. I really hate it. I don't have much success when I clean it. I usually get shorts and all sorts of weird stuff going on. But this time I'm gonna try to give my best, so we can have a good video about it. I'm not sure if I'm gonna finish it today because it's quite late, but if not, we're gonna continue tomorrow. In the past I was using the knife to clean this, but lately I found out that this is a better tool because it doesn't scratch the it doesn't actually scratch the board, you know. So when I use that knife, I often get scratches on the board, so if there are tracks under it, I might break them. Sorry if I'm not talking too much, but I'm really focusing here. Yep. Alright, so I think we got all the sides cleaned, and I think we can just proceed in removing the CPU. Clean this here. It's gonna be a challenge to remove the CPU because on this model we have parts all around it, so there's actually no entry point that we can use. So I think I'm gonna use something like this, like a blade, and I'm gonna force it like that because I don't really care about this CPU. I'm gonna force it like this, and yeah, we cannot do this under the microscope, but I'm gonna resume it with it. I'm gonna set up the hot air to 355 and 365 and 65 air. 365, 65. Cool. So we said we're gonna pry this CPU with this tool, like this, so we don't disturb the surrounding components. And I'm gonna use a copper plate here over the PMIC. And now we just heat up, and slowly heating up the board evenly. Yeah, I know you cannot see much, but that's life. I can't see also. I usually like to work under the microscope, but this case, because the nozzle, you see how big the nozzle is, and it's straight, I cannot go under the microscope. So I'm not sure if this is such a good idea with this tool. I've never done it with it. I hope I'm not disturbing the surrounding components. Okay. Let's see how much damage I did. This was very bad in my opinion. Let's look under the microscope and see what did we move. So actually the surrounding components seem okay. It doesn't look like I really bothered any of the components out there. So we seem fine. Let's see the CPU. How does it look like? It's good. I'm gonna keep this CPU for a video about cleaning the CPU. Yeah, because it's good for that. We can remove also the copper plate, which is extremely hot. Alright, so now we need to clean this crap here. It's not easy to do it. I don't see any solder balls around the PMIC, so I think everything went quite well on this. Yeah, it looks good. So first thing first, I'm gonna apply flux, a good amount of flux, and I'm gonna come with a solder iron with some 148 solder paste. Let me see. I'm gonna change my tip because I currently have installed the tip that I use for wicking, but we are not wicking yet. I'm gonna use my bevel tip, and let's give it a try. So using this paste, which you can see, some leftovers. And I'm just gonna gently try to replace the existing high melt solder with this low melt 148. And in this process the tip will also scrape out some of the underfill. It's not gonna be that smooth. But I think it's gonna work. I'm constantly rotating the board. I don't know if you can see everything. You don't have the full picture that I have, so yeah, but that's life. Let me rotate it again. think the tip is at 380, but yeah, you can see the soldering station there. You can also see the temperature that is currently set. I'm being a bit aggressive here in the middle. There's lots of ground plane, and the underfill here is very thick. But I think it's going away slowly but surely. I'm trying to actually melt it, and it's kind of combining with the flux in a nasty paste like that. Doing also the sides. Yeah, so it's good. Good. So now I'm gonna take this tool here and I'm removing this nasty goo. Okay. Now we add more flux. I'm gonna replace the tip, and we can start wicking it. Let's see a bigger picture like that. Perfect. So let me cut some wick and replace the tip with the tip I usually use for wicking. Okay, how do you see it? I think you see something there. I see almost nothing, so I'm gonna put it like that so I can see a bit better. It's more important for me to see than for you. The first row of pads, it's a bit complicated to wick because I didn't get that close with the small to the low melt solder, and this is still containing some high melt crap. I don't want to disturb the surrounding components. I'm still working on the corner. Okay, so I think the corner is fine. So first thing, when I'm wicking, I'm attacking the sides. So I do the sides first, all 4 sides, and then I'm gonna handle the middle. The middle is easier because we don't have to pay attention to any components around. Yeah, so again here we have this corner that is still with high melt solder. Okay, we're good. Can rotate it now. Perfect. And start from here. And there's quite a lot of underfill on the sides. But the wick is extremely thick, so it has a lot of thermal inertia. Oh, now I see what I've done here. So when I've removed the CPU, I've moved this IC here. You see it? It's not straight. We're gonna handle that in a few. I knew I'm not doing it properly because I couldn't see anything. But this model is one of the most difficult CPUs to remove because of the surrounding parts, components that you can damage. Also, the good thing is that the PMIC is not on the other side, so it's on the same side here near the CPU, so you don't get a lot of solder balls by heating up this part. Okay. Have one more thing to do here, and I think we are quite good with it. I think this looks pretty clean, right? Now let me handle my tip for a bit, because when you use the tip, it's getting damaged when you wick with it. Okay, so now, well, the board is still a bit warm. Let me try to drag again all the goo from here. I wanna drag it away. Alright. Okay, so let's have a look here on the damage we made. This doesn't look good at all. So you see this chip is pushed from here, like in that direction, and this cap is pushed. So let me replace the nozzle. So we have a hefty big nozzle. I'm gonna set the hot air to 380 and 50 air, and now I'm gonna add a bunch of flux here, and I'm gonna try to reflow this and repair the mess I made. I think this one should be actually reballed. Definitely I'm gonna have to reball this one, because I think there are short circuits there. Okay, so it came back in place. Let me handle these caps. Okay, so they're gonna be removed. Need more flux. Okay, so I think we're good now. Everything is aligned properly. Let's handle this chip here. I'm gonna use some low melt here. This is not the perfect tip, but I'm a bit lazy to replace it now. Okay, let me try to wick it. I'm gonna use the smaller wick. The thinner one. Okay, looks good. Did you see anything? I don't know. So if I set the board like this, for you to see in the middle, I see it very down low. It's a bit difficult for me to work, so actually this is a better position for me. Okay, I think it's good. So now let me give it a good clean. I use my alcohol bath here. And I need a brush. This is the first time I make a mess when I prepare a board, but as I told you, it's the first time I try to remove a CPU like that. Usually I sacrifice some parts and I use a different tool to pry it up. Now I was stubborn and I thought it's gonna go faster, but we actually made things a bit worse. No problem. It's not always working as we want, so we can fix it. We can definitely fix it. Alright, we'll get back soon to the board. Now let me find a stencil. Let me see a stencil for 13. This is the stencil. Good. Alright, and let's take care of that part that I have removed, the chip. Let's see how it looks like. It looks like gooey. You can see it now too. Okay, let's add some flux. Let's use some 183 solder on the tip just to clean this. This is still really bad. It's interesting that this tip is magnetic, so when I close it, this magnetic pad is sucking it. Alright, let's clean it a bit. Good. Okay, so obviously this doesn't fit it properly. Look how it looks. But we're gonna try it. We would need a finer one. Alright. Let's see. I'm gonna use 330 and 30R. Good. Incredible, now I can't remove it. This is crazy. Some crazy shit. Fantastic. Jesus Christ. So it looks good. We put all these boards back. Let's get back the board. Alright, and now let's look where the first pin is on this chip. A1 is here. So in our microscope view is lower right. Okay, I'm gonna put it here. Okay, pin 1, low right. Like this, you can't see anything, of course. And it's gonna be something like that. Alright, 350/50R. And it's back in place. You can bump it, all good. Now we need to clean this part here. So we set it to 40 to 30 R, and begin the cleaning here. clean it first. I think we're good. Now I made sure that none of these components are actually being desoldered. So these are all extremely important, the ones that are surrounding the CPU. So it all looks good. Now we need to clean these holes here. Still have some glue here. Okay, that's fine. So the holes where the deep trench caps go, they still have underfill inside. So this needs to be cleaned properly, or because the CPU will not sit properly if they are not cleaned completely of this underfill. So we need to make some room for the DTCs. Okay, so we're fine. I'm gonna have a look over here on these oxidized pads in the corner. Okay, but they're fine. Okay, perfect. And the final thing is to remove the logic EEPROM, and I said that for that thing we need to remove a shield on this particular model. Let me clean my workplace a bit. And the shield is actually on the other side of the board. It's this one here. Alright, for that we need to remove this glue that is between the NAND and the shield itself. I'm gonna use 240 and 30 air. Okay, I'm gonna need to remove this one here. Okay. This scrap is very hard. Okay, and that was it. Okay, this part here. Alright. And now is the tricky part, because we need a lot of air and a lot of heat. So first I'm gonna try to protect the land with this shield. Right. So let's go to like 70 air, 80 air, 420. And let's hit this crap. I want to avoid as much as possible hitting the land. Alright, so it's coming off now. Perfect. Shield is off, and here we have the logic EEPROM, which we need to remove. Fortunately this stencil doesn't help us because it's quite big. I need to find a position here that I can use to grab this one, because it's very small and there's a lot of surrounding components. Let me see, this tweezer is better. I don't know. And I'm gonna use here some liquid flux, because I want to keep the solder balls intact. I'm not gonna rebuild the original one, so this is just liquid flux. It helps a lot. Okay, let's protect the land again, and let's use 380 50 air. You see this liquid flux is boiling, and all the alcohol in it, it's evaporating, and everything that remains is just pure flux. Just don't want to disturb any of the components around it. I'm waiting for it to actually melt. There's something wrong with my heat gun, but it's taking a lot of heat here. Okay, give me more air. Now it's moving. Good. We don't need this one anymore because we're gonna use the original one from the other board. Now I'm gonna clean again this board, but I need it to cool off first. Let's have another look here and see if we made any solder balls, but no, it looks good. Yeah, all fine. So now we can clean this one. So that flux is not bad, you don't need to clean it, that we used for liquid flux. So basically it's this one, is this thing, you see here, this, the rosin, and I mix the rosin with the alcohol in a small bottle, so I just smash the rosin and I drip some alcohol, and the result looks like this. Yeah, so when you put this on the board and you heat it, the alcohol evaporates and everything that remains is the rosin. The rosin, compared to the flux that we use in the syringe, is not corrosive when it's not hot. So you can leave it on the board. It will protect the board from water damage. It's very good. I just clean it for cosmetic reasons. Yeah, so this is it for this video. The board is prepared now. The only thing we need to do is actually test it. So for testing it, I'm interested in two things. One, we apply power to it and it shouldn't take any amps, shouldn't consume any current at all. And second, I am interested if we have like between 1.5 to 1.8 volts on the power button. So if we have that, it means the PMIC is working, and if there's no power consumption, then it means that we do not have any shorts on the board and the board is ready to be used as a donor. Okay, let me clean this a bit. When you clean the underfill, all that underfill goo is flying around on this, and then it gets to my hands and it's a bit annoying. Alright, so let's test it. Get the 13 Pro Max squid on it. Alright, you can see the power supply there in the corner. I'm gonna power it on, and there is no consumption. The spike that you saw is from the NFC, the 7 milliamps. So everything is good. I'm also gonna prompt it to boot. It shouldn't take anything when prompted to boot. Let's see, where is the connector? Right here. I always forget which is the pin. I think this one. one. Yeah, so no power consumption. I'm gonna try them all, but I always forget which one is it, or maybe it's that one there. I don't know. Let's take the multimeter. Let's put it in voltage mode. You can see it here. Yes, you do. Alright, so put this way, maybe with a light. Yeah, it's better. And now with the black probe on the NAND on the ground, let's see here, we have like 1.6 is good. So that was the power button. Yeah, so this one here, 1.6 volts, we're good. It means the board is ready to be a donor. So this is it. This is the scope of the video for today, to show you how to prepare a board for a transplant. It as you see, it looks very good. Everything is checked, and we can safely use it. If you need a data, a backup of the data, then you're gonna have to move also to remove the NAND and put the original NAND, but this board is not for that. It's for a working phone that we don't need data of. So this is it. Thank you for watching. Leave a like and subscribe if you enjoyed the video. Bye.